Let's solve an SAT problem. Here we're given a square ABCD that has diagonals on the x and y axes, and we're asked to find what is the area in square units of this square. There are two ways to approach this problem, and we'll learn both ways. The first way to approach this is recognizing there are four separate triangles, right triangles here, and we can find the area of one triangle and just multiply that area times 4, and we'll get the area of the whole square. So let's try that one first. So what is the area of one triangle? The area of one triangle, area of triangle is going to be equal to 1/2 base times height. The base is the x value, which is 5, and the height is the y value, which is 5. And so this is going to be 1/2 times 5 times 5, which is going to be 1/2 times 25, which is going to be 12.5. And so the area of the square, as mentioned, is just 4 times the area of the individual triangle, because these triangles have the same area, and 4 of these combine to form the area of the square. So this is going to be just 4 times area of the triangle, which is going to be 4 times 12.5, which is going to be 50. So the answer is 50. Another way to solve this is with finding the hypotenuse. So we know that each triangle is gonna the triangle itself is a right triangle, and so the hypotenuse is going to be equal to the hypotenuse square is going to be equal to 5 square plus 5 square, so the base square plus height square, which is going to be equal to 25 plus 25, which is going to be 50. So hypotenuse square is 50, and so hypotenuse is going to be square root of 50, which is going to be equal to square root of 25 times 2, and that's going to be equal to 5 square root of 2. Now this hypotenuse itself is actually the length of the side of the square, okay, which is, we can call it L. And so the area of square is just L square, which is going to be equal to the square of 5 square root of 2, which we already found was 50. And so we can get the answer both ways, by solving for the area of the triangle and multiplying by 4, or by solving for the hypotenuse and squaring that to get the final area of the square.